Hello, welcome to this episode of Mechatronics 101. Today, we'll be talking about making a PCB in KiCAD. Now, before watching this video, you should have already watched Pierce's video about making a schematic in KiCAD, as this will pick off exactly where he stopped. So, an entire schematic that we'll be using is from Pierce's video. Again, if you haven't watched his yet, highly recommend it. Otherwise, you can't make a PCB without a schematic. So here we go. Um, After making the schematic with Pierce, you should be at this step where you have a schematic and you did all of the assigning of footprints to the symbols. Now, the next step, how do we get this into the PCB world? Well, from here, the thing you have to do next is make a net list. Now, a net list, we're going to click this button and just click Generate Net List. And it'll pick the default folder for wherever your project is. So this is fine. You just hit Save. And now if we go ahead and go back to this project screen, we'll have a new file, which is our net. What this means, we can open this up. Oh, just kidding. You can't open that. Um, you can open it in the PCB screen, but it's essentially just how it links these symbols onto the PCB. And so make sure you click the Generate Netlist before going to the PCB. So after that, if you want to come to your project screen, and there should already be a PCB file available. I think it makes it by default when you create a project. So we're just going to go ahead and double click that, and a window will pop up. And this is the screen for the entire PCB. Now it's blank because we don't have anything on it, and we got to do a couple of things. So first, what I like to do is change the screen or the size of this red paper. Right now, if we click on this page settings button, it's saying we're using A4 sized paper, which, if you're unaware, is a kind of standard for large engineering paper documents, kind of like poster size a bit, maybe a little bigger than that. But for us, we are going to be wanting to use a size paper, which is your standard printer paper that you'd be using for just about most stuff. Now, on here, we have a few different options that we can enter. These options affect this lower right-hand corner details of the paper. So what we're going to do is go ahead and transfer the date onto here. Revision, this just means which version of the board you make. So usually what happens is you'll make a board and you have a design that works and everything, but sometimes that is not the case, and you want to change how the design is, and maybe there's a faulty connection in it or just something you want to change. So you would make a new, or you would edit the PCB design and note that as a new revision. So for us, we're going to do revision A, signifying that's the first ever revision. The title, this is a joystick follower. Okay. The company, I'm just going to put SDSU Mechatronics, but this can be whatever you want. And if you would like, you could put some comments, but I'm not really going to fill that out. So we hit OK. Now if we look in this corner, we have our title, our company, the file it has, what rev it is, and other details that are automatically set. Now, also, the paper size is smaller. So that's what that did. Okay. So next, what we need to do is we need to get all of our pieces onto this sheet. And the way to do that is by clicking this Update PCB from Schematic button. And what will happen is it will try to link the two. And as you can see, there's already some changes that have occurred. If you have a bunch of text here, that means that everything is working well. If you have any errors, it might have a problem with the linking. of footprints to symbols, so maybe go back to Pierce's video and make sure you did that correctly. Otherwise, we can just hit Update PCB, and we can already see, after I hit close, we can already see we got all these parts right here. Now, what this called is the, well, you spawn it in by left-clicking on wherever you want to put it. And what you have is all of the linked components that was specified in the schematic. And you got all of these white lines that are just everywhere, and they call that the rat's nest. What that means is each trace from the schematic, let's go back to the schematic, each wire on the schematic, what it does is it connects two nets together. So if we look here, we have A1 is connected to H2, and it creates this wire in the netlist file that we made earlier. And what the PCB does is it takes that link and draws it with this white line. So every wire connection has this white line, just for reference point, because they're not technically, there's no trace, is what you would call a wire on a PCB, but there's no trace connecting them yet. That's what we have to do as the PCB designer. All right, so we have an Arduino right here. We have our joystick footprint right here. We got two LEDs, two more LEDs, and it even says what color the LED is. We have our 4 push buttons, and we got a lot of resistors that were all specified in the schematic. And there's another one. So what we need to do is make this all neat and organized and just visually aesthetic as we can. There's some rules and tricks of the trade that I'll be sharing along the way of doing this, but without further ado, let's just get into it. So the first thing that I need to do is, or that I typically do, is I kind of spread things out a bit so I can just look at what I got. So in order to move individual stuff, you could either click on the symbol that you want to move, just like in the middle, or you can hover your mouse over an object and actually you have to select it. So left click to select, and you can hit the M key to move, or you can just click and drag to move. But sometimes you can't do that too well when you have them overlapping, because it won't know which object you're trying to select. So I want to select this switch 4 to move it out of the way. So I selected it and I press M and move it out of the way. So yeah, there's a lot of hotkeys that will be used in KiCAD that will help you get used to, or speed up rather, your PCB building process. So the first thing I usually do is just spread things out. Maybe group a little bit. As you can see, there's this wire here and this wire here. So we know those are going to be kind of together. So I'm going to group those together. I'm going to group this around here. A lot of things like this. So it's kind of a lot to do, but that's all right. It's the best part about this is PCB designing. It's not that bad. It's really creative, and it's something you can just put in music while doing and not think too heavily about. And in my opinion, it's just relaxing. You just have to organize stuff, and it's kind of like a just organizing craft, you could say. So we got all our buttons over here, and we got some LEDs. One thing to keep in mind, think about the functionality of whatever you're designing. In this case, is a joystick. And we have 4 buttons and a joystick right here. So I kind of know that going off of typical controllers that buttons are usually on the right side of the board or the controller, and the joystick is typically on the left side. So we're gonna kind of want to orientate it like that. Um, so we can move all these out, make them in the appropriate places. Now, what you see on the right here, you got these yellow circles. These are all the pads, meaning these are all the points that you'll be soldering the components into the board. They are straight copper, while the rest of the board is it's got a silk screen material over it, and won't allow, if as long as you order the board, that is, from a professional manufacturer. There'll be a silk screen over it, so that way you can't really solder to anything else besides the pads well. So that's what those are. You got these turquoise lines, which, as you can see, they can all be mapped to whatever these layers are. So the turquoise silk screen, that stands for the front silk screen, meaning on the front side of the PCB, there'll just be this outlines and writing will pop up. But as you see, this gray one, this one is for fabrication, front fabrication, and if you hover over it, it says footprint assembly. This is more just so you can get an idea of the mechanical dimensions of the piece itself. So typically it's just like a square encasing the entire footprint of it. That will not be printed onto the board when you make it, but the turquoise will be. Just keep that in mind. Okay. So we're just kind of spreading things out right now, seeing what we can do to keep it organized. One other thing I noticed right away when looking at this is we have this outline of an Arduino. Now, just by looking at it, I can kind of tell this, if we were to try to fit everything inside of this square, that would not be really possible because, well, it could be possible maybe, but it would be really crammed in. I don't think that's such a great idea to cram it that much. We like to give it a little bit of space. Luckily, just because there's this outline, that doesn't necessarily mean that's going to be the size of the entire board. Going back to what we said earlier, if we zoom in, this is actually just the silk screen and the footprint outline overlapping each other. So on the actual board itself, there'll be an outline of the Arduino, so you know how to basically connect the Arduino on top of the board, or actually the board on top of the Arduino. So it gives this outline. Now, because we want to make our board connect on top of the Arduino, we need to think of where this silkscreen should be. Now, typically, whichever direction is pointing up is considered the front of the PCB, and the one that's facing down is the back side. If the Arduino is supposed to sit below the PCB that we are making, we kind of want the silkscreen to be on the back side. So what we're going to do is right-click after selecting it, and we're going to click Flip. What this will do is it will invert everything to be on the back side of the board. And if you look, it's all purple now because, oh, okay, yeah. It's all purple now because purple is the back silkscreen. So it changed all the layers necessary to make it work. All right, so this is just gonna sit, everything else will be on top of the board, but this silk screen, it's important that we put it on the bottom because of how they mechanically connect to each other, the Arduino and our hat for it. Okay, so we have this joystick here. These lines, they stand for the back fabrication. Now, knowing the Arduino, this is going to be a little bit of mechanical constraint because what's going to happen is this is where the USB port, I forget which type of USB, maybe USB-A, but I'm probably incorrect about that. Anyways, this is a port that has some volume that would extrude from the board and possibly interfere with any parts that would be on top of it. Additionally, this is a 9-volt input of the Arduino, and it also will extrude out from the board. So we kind of have to avoid overlapping stuff on it because they would collide and you just wouldn't be able to plug it in together. So the joystick, we know we want it to be on the left, and it's a good point to start because it's pretty big and a lot of things interact with it. So starting here and building around it would probably be a better point. So what we're going to do is kind of just sit it in here because there's enough clearance for it, and we kind of want to get it as left as possible just because it'll give us more room for the buttons. Okay, then after we have placed that, I think next would be appropriate to do the buttons. So I'm just moving this out of the way, moving this out of the way. Next would be kind of appropriate to do the buttons. So a good thing to do is to kind of have the schematic ready and available to see if there's any notes that indicate which buttons kind of go to what. In this case, it doesn't matter too much because each button is just going into a pin of the Arduino, and it's up to us which ones are going to be going up and which ones are going down. Looking at this, I see that each switch kind of goes in a nice order in terms of how it connects to the Arduino. So I'm going to go top to bottom. So the top one is switch 1, so I'm going to put switch 1 at the top and build down from that. So let's move it over. And I think what I'm going to do is going to try to line it up with the top a little bit to the best of my ability. I think that's about good there. Let's see, we might have to adjust that up just because everything is so much wider. So what we're going to do, yeah, we're going to have to push this up. That's all right. So what we'll do instead is kind of line the center up with that center. So we'll push this maybe to right here, center to center-ish. Move this one up. And it's okay for you to overlap the fabrication words because, again, they will not be printed on the board itself. So here we go. We'll go right about there. And that almost looks center. We'll move it a little bit, actually. So there's a lot of tinkering to make it kind of visually pleasing. And then we'll put the fourth one down here. We'll give it some space so the actual silkscreen text can be visible. So let's move this one down too. This one down. Yep. Move this one up. Okay, so the turquoise we want visible. Anything else can kind of overlap, unless it's a trace. Now looking at this, I feel that I don't really like that it's off-centered. So from the bottom to the top. So what I'm going to do is I'm going to select the Arduino. I'm going to move it down just a little bit. There we go. That's a little more better. Let's move this to the right just to make sure we're still clearing that. Okay, I like that a lot. So what we'll do is kind of start thinking about where to go because there's a lot of lines everywhere and it's a little bit of a mess. Well, some of what you'll see is there's a lot of common grounds. So grounds are going to make up most of the lines, and that's not an issue because with grounds, what we'll do in a bit is we'll cover everything with a ground plane, and it will connect everything that's ground together, and everything that's not ground will not be connected. So we can save those till the end. What we'll instead focus on is any power pins. So if we look at the schematic, we have a 5-volt power pin, 2 of them specifically, that kind of deal with a nice chunk of everything. So let's see what stuff is got a 5-volt net. You should say 5-volt wherever there is one. Here's one. R1's got 5 volts, so let's go ahead and move that close to something that's got 5 volt. I automatically know this is also 5 volt because there's this line connecting it. So these go together in a way. But they don't necessarily have to be together. See, there's another 5 volt here. Sorry, a lot of zooming. So to scroll in and out, you just use your scroll wheel and yeah, okay. So we got 5 volts there. We got another one. That's a 5 volt pin itself for the Arduino. That's nice. We got these two that are 5 volts. Yep. Okay. So let's put this up here and this one up here as well. Okay. And we might have another one. If not, that's all right. Okay. I'm not seeing any others. This is all right. Okay. I believe. Oh, didn't mean to do that. Okay. So let's handle some of these 5 volts. How about that? So the 5 volts, they all seem to connect to either this, oh, not that one. They connect to, if we follow it, it seems like they connect to here. So we're gonna kind of need to figure out a way for them all to connect to here or to connect to here. It just needs to connect to some 5 volt pin in general. Because there's so many of them, what I'm actually going to do is wait to assign them to a spot because they're kind of flexible a little bit. Because if you connect, let's say if we connect just this wire or this trace or pad via is the right term. If you connect this via to this via, you could actually, instead of having them all connect specifically to this via where all the wires go here, what you could do is kind of daisy chain it where we have a connection from here to here to here to here to here and back to here, and they would all still be in parallel because of how the PCB works. And in fact, we're going to be doing that when we set those up. So that's why these are a little more flexible and we can kind of push those off to the side. So now that we chunk those out, we kind of have a little less components to worry about. So I think what I would like to do, oh, accidentally moved this, that's all right. I believe this would go somewhere around here. I think I would like to do the LEDs first, because the LEDs, I know specifically that they kind of need to go around this joystick. So let's see how we should orientate these looking at this. Similarly to the buttons, it looks like they don't need to be in a specific order because through the logic of the code that will be written for the Arduino, each LED will be specified, but on what it should do. But I think it would be helpful to kind of keep an order based off of their chronological annotations. So we'll do D1 at the top, similar to the switch. We'll do D1 at the top, and we will go around circle. So D2 will go here, and I just kind of push it on, place it on, and then tidy it up afterwards, because it's easier to get an idea once everything's in place. So we put that there, and we put this last green one. So this green one indicates that the joystick is being clicked, and so I think either up here or on the right would be good. I'm thinking on the left, just because I want to use this space maybe for some resistors. Okay, so we have everything set into there. Now, still got all these lines everywhere. I think now is good to kind of refine. So we have all these grounds. Like I said before, the grounds don't matter too much where they're orientated. So usually where I see connections, I will orientate the component to face the connection it needs to make. So like these two will have to connect. So I'll keep that oriented like this. This one will have to connect to a resistor. Um, so that's kind of up to where the resistor is. But since I said the resistors will be in the middle, that's good. This one will be connected to another resistor, so that's good. And same with this one. So we're going to have all of the grounds facing the left. All right, so now we have that set up, which is good. Next, maybe we have four resistors that are not. Oh no, we have five. I lied. Sorry. 5 resistors that connect to each LED. So we'll figure out a way to do this. I think it's better to start where it's a little more convoluted, because these ones will be kind of more particular where you place it, like because there's not a lot of real estate around it. So we'll do, let's see, we need to do D1, so we'll follow the trail down to here. We know it's this resistor. Okay, kind of seeing that we're all crossed up. So what I'll do, you can, if you have an item selected, yep, if you have a component selected, we said the M is to move, R is to rotate. So I use that to rotate around. It's faster than this other method, which is just right-clicking the item and clicking rotate clockwise or counterclockwise. See, this is not as simple. I prefer just hitting R. Okay, so I like to kind of just line it up nicely to start it off and then adjust it from there. This is a really good connection because it's right up next to the diode. However, I'm seeing that a lot of things are going to need to connect at these pins. So this might not be the best way to do it. So in fact, I think what I'm going to do instead is have it where all of these resistors will sit underneath these pins one way or another, and see how that looks. So we'll do this one next. Oh, wait, no. We'll do, yeah, we can do this one. This is fine. So this one is going to connect right here. Now it's going to be kind of tight. We're going to have some overlapping like this. So what we could do is, if we want these resistors to be exactly next to each other, what we can do is select just the reference and move it down, because remember the turquoise will be printed onto the silkscreen. We'll move it down to below the resistor, so that way they can be exactly lined up with each of these pins to the best of our ability. So next, I'll go ahead and click this one. So we can already see it's getting a little bit tight. So it's not going to be exactly perfect, but we can kind of make some room. This one can afford a little bit of movement. So we could fit this one in, R4 that is. Let's select R4 and move it down here. Okay, good. Then we will get R6. See how this fits. Yeah. So it's getting a little tight, but this is all right. This is okay. In fact, if you would like, you could even just hide all of those numbers by clicking on the right-hand side on the front fabrication. So that way you're not as bothered by all of the mechanical sizings. You still have this outline, so it still gives you good reference, but you don't have to worry about all those values in the way. Okay, I'm just trying to select R6. Here we go. I'm going to move it, rotate it. Very nice. And we have one more resistor that goes at the top here that we will connect like this. All right, so, and we'll move the R5. Oh, hold on. Am I selected on it? Oh yeah, I am. My bad. Okay, R5 goes here. Now, this could work. I think what I'm going to do is move. Well, yeah, this I think is good. What we can do to check is by connecting, seeing how these ones perhaps connect. Because looking at it, each of these, most of them actually, are either going to connect up here or connect down here. But we'll see. So like 21, let's look at 21. 21 connects to this pad, which connects to this pad, which connects to here. So like I said before, as long as the line has a reference point, it'll auto adjust itself based off of if it's in parallel or series. But because of the document, how it was made, how the schematic was made, we know that these resistors are indeed in parallel in the way that they connect to their, maybe not parallel actually, that's not correct, they're neither, but the way that it's worked, there's multiple points that it could connect to is what I'm getting at. So let's go ahead and put this, right up next to the pad and see where this one goes. So that one's can either go up here or to this pad. I'm thinking we put it down right about here because we will sneak it underneath footprint. Okay, R7. We could see R7 will be connected to this point, which is not bad at all. We can connect kind of just like right around here, which leaves open space up top for B1, which B1 I think goes straight to the joystick. So we're going to put B1 about here. And last but not least, R9. R9 at this point, let's see, it doesn't matter too heavily, but right there looks good to me. As you can see, it's already kind of neat. There's not too much disorganization going on. In fact, we can even line this up better. Start our 5-volt chain. Let's move this down. We got some space. We could kind of move it back a bit. I think this is good. This is looking great. It's looking pretty organized. Let me center that. Pretty organized. There's a lot of space. Everything is kind of not jumbled around. Let's go ahead and refine these to be a little more center before we start our tracing process. Okay, I like that. Yep, this is good. I see there's a little more space here compared to the left side, so I'm going to move this out a bit. Try to match it better visually. This looks good, but I think I want to, no, we'll move it. Yeah, no, that's good. Looking nice, looking nice. Good, good. All right. Now we can start the process of making the traces. So the trace, again, is just the wire connecting all the pads. And the way to make a trace is by selecting the Route Tracks button on the right-hand side, and a new cursor will pop up. And when you want to make a trace, you just click on whatever trace you want to make. So you also need to make sure you're on the correct layer. So you can make traces on the front and back layers, and in fact we'll be utilizing both layers to make this layout work. So yeah, I click the front copper layer. I'm going to start at the top right here and see if we have enough clearance to make a connection directly to this. So I'm going to left click on pad 1, and yeah, that's as clean as a connection you can get. That's really close and nice. Most of the time, the connections you make are not gonna, it's not gonna matter too much how far it is, but keep in mind sometimes if you're dealing with signals, analog signals that need to be analyzed and stuff, the further the trace is, it loses some of its strength. And also the width of the trace itself, which is controlled up here. We'll mess with that a little later, but the width controls how much current passes through. Well, the width and the surface area of the trace, rather. So the length and the width combined control how much current is physically capable of passing through the trace. So most of the time, you can kind of use the default 0.25 millimeter width, which I'll be doing for this. Okay. This one should, actually, let's change this a little bit. So one thing you want to keep in mind when you're making traces is try to avoid right angles, or sorry, acute angles at all points, at all costs. The reason for that, like right here, it's an acute angle. This is technically an acute angle too, I guess, but it's not as bad. What we mean by acute angles that are a little more worrisome is ones that are really close, or like maybe 30 degrees or less. The reason for that is because when the manufacturer makes the PCB specifically, the traces, when the process they use it, acute angles, they can sometimes build up. They can build up acid that will erode the trace itself, and you might see like kind of like a rash supposedly, or a burn at an area where the board would be made, or where the trace would be, and it can damage your board, and it wouldn't give an accurate or precise reading of what you wanted. Not reading, but function. It may not function properly. So it's good to avoid. It's good to avoid any acute angles if possible. I see. So it looks like I mistaken. Actually, no, I didn't. Okay. So we're just going to draw some more traces. I like to kind of also make these a little organized, like so. That's a nice one. So we got these 45-degree angles, which are good. But if it was perhaps like this, like that, I would avoid this right angle at all costs. I would rather put, goodness, sorry. I'd much rather put a 45-degree angle one, because there's not even a chance of this creating that acid trap. Okay, so just some more button tracing. And this is what I mean, like, is after you did the layout of everything, there's not too much thought that's going into it. It's just making sure you connect things properly. And in fact, it won't let you connect things that shouldn't be connected. So we'll save the 5 volts. We can, for the switches, we need to connect all of these together for the switch to function correctly, or the push button to function correctly. So those are straightforward ones. Same with this one. It's just directly in. We got this pad right here. We'll go up and we'll go over here. And you can, the traces will be underneath the silk screen, so it's all right that it's showing, it's intersecting the words. It won't, on the actual board itself, the silk screen will completely cover it. In fact, that's what makes the board green, is the silk screen itself. Okay. I think I'm going to sneak a wire down here, all the way down to here. And it's okay for it to go underneath some components. If it's an IC, a chip, I would avoid it. But for resistors, it's not a big deal. The reason being, resistors are much easier to take out compared to ICs, unless you have a socket where the IC just plugs into something that's soldered on the board. If it was soldered to the board and let's say the trace blew up or something, or got damaged, you would have to unsolder the IC to access the trace, or even figure out why your board's not working. You'd have to desolder the IC to check if that trace underneath is good, and that's kind of just a pain. So just if you do it underneath IC, just be aware that that could be a problem. All right, so it looks like we have this connection here. It's pretty straightforward, so I'm just gonna go for that. Now I'm just making sure that I'm keeping rules, and there's not too much to be said here. Like I said, no more right angles. Just trying to get all the top layer ones. We'll save the 5 volt. This one could be 1. We'll do this one. So we need to somehow get this over here. And a lot of these traces, right, I'm laying them out now, but in the future, if I notice like there's no possible route to a place on the top layer, like I'm seeing for a couple things, then what I'll do is I will use the bottom layer. So let's just look, see if there's any more that fit on the top. That's good. See, this one is an example of one that would probably fit better on the bottom, but we'll hold off on that. Just looking, seeing what there is. This one would probably be better on the bottom. Same with this one. Yeah, let's go to the bottom. Okay, so I clicked the bottom copper, and now if you see, if I try to create a trace, it's green, signifying that I'm on the bottom layer. So we're gonna bring this all the way down to here. Let's go ahead and sneak it right in between. Let's do it like that. That's a little better. Yeah. Okay. So we got that. This one needs a connection, which we could do right here through this. It's a little finicky sometimes. Okay. Well, I'm trying to pull it in as close as possible, so that way I'm not using too much surface area around here for red traces. Oh yeah, here we go. This is going to be a problem. So as you can see, we need to get B1 all the way over here. However, there's both a green trace and a red trace. So an easy fix actually would just be to reroute this green to be around at this side, so that way we don't even have to worry. And we, oh, hold on. Let's go back a little bit. this. Oh, okay. Yeah, there we go. Nope, 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 nope. Sorry. Okay, select our trace tool. We'll move around here, down. In fact, we could actually come down here. Probably be better. Oh, did a little too early. When you're done making a trace, I should have said this earlier, you can double click escape and it will stop it. Or what you can do is right click, and I'll show you on this one. You'd right click. Let's see, go here, click. When it connects pads, it's all right. It automatically ends it. But if I were to make a line here, let's say, I would right click and hit end track and it would stop there. Delete that. Just a lot of shortcuts and tools or tips that would help. Okay. Let's missing any major stuff here. This is a signal we need to deal with. Seems that we could probably sneak it right here if we moved this a little bit on the red on the top layer. Oh, okay. So it selected this, change to the top layer. What we'll do is bring it up, and over. Okay, that's not bad. So that way there's enough room to squeeze a trace in between. We want to make sure there's enough clearance for the traces as well. We could do that. That's all right. That's not bad. Okay. We got 5 volts. I'm thinking I'm going to do the 5 volts on the bottom layer. We do need, however, going to need to somehow connect to here. And I'm not seeing anything that's going to be directly accessible. Because like I said, I want to keep the 5 volt. Oh wait, hold on. I just saw something. Yeah, let's just do the 5 volts. So that way we can deal with that now, since a lot of stuff's already connected. So 5 volt. Let me make sure I'm still recording. Okay. So 5 volt. Since it's a power trace, a good rule of thumb is usually power is going to have a little more current going through it, and to allow for current, we should increase the width because this is a little narrow for current. And so what we're going to do is we're going to click the edit predefined sizes. A new window pops up, and you got all of these different presets that you can choose for different design rules. What we're going to do is we're going to adjust a width or add a width, and we're just going to use 1 millimeter because that is good enough for our application. If you're curious to figure out what width is best for your signal on your PCB, they have, oh, hold on. I'm just going to disable this. Okay. They have PCB calculators that you just have the desired current you want, how long it is, and then it'll give you, or how long your trace is, and then it'll give you the width that you should be using, just through some basic algebra equations. And I believe KiCAD also has one built in, but I have not used it, so I will not be showing how to use that in this video. But if you're curious enough, I'm sure there is many tutorials out there just for that. So in this top left corner, we're going to select track, and we're going to do the 1 millimeter width that we just created. And we're also going to go to the bottom layer. And now if we create a trace, you should see that it is much wider compared to the 0.25 millimeters. So this is exactly what we want. And now we're just going to we're just going to connect all of our 5 volts nice and neatly. And making sure there's no other 5 volts that are down here. It looks good. Yeah, we're going to bring this up. We're going to bring it up. Actually, yeah, we're going to bring it on this side. So that way we can connect it here and still allow access to this pin. So those seem to be all the 5 volts that I can see. Looks like all the 5 volts are connected, which is good. And we're not going to be using the 5 volt or the 1 millimeter width trace anymore. So we're going to go back to the 0.25 in the top left corner. And we're going to finish up any more traces. So we got this one right here. That. Oh, I see. So this is interesting. We could just do this on the bottom layer and totally avoid the problem. I almost would have arisen. Oh, make sure you select your trace tool. There we go. Having a little technical difficulties there. Okay, there we go. And that will go into there just fine. Here's a fun one. Here's a fun one right here. So we need to get this onto the other side of this bridge. But we have both colors again kind of in our way, both the top layer and the bottom layer. So what we're going to do is use a small via to essentially go where it's green, we're going to go under it with a red trace, and then where it's red, we're going to go over it. Oh, sorry. Where it's red, we're going to go under it with a green trace. But when it's green, we're going to go back over it on the red trace. We'll be switching back and forth between the planes. So because red's right here, we're going to start on the green. And we'll kind of get to right around. Let's do it to over here. Okay, escape. What we're going to do is we're going to click this via button, and we're going to place it right onto the trace so it knows what net it is. So right here, it knows that it belongs to that trace's net. Otherwise, if you just clicked elsewhere, you would have to right click and go to its properties and choose what net you want to use, which is a little bit more tedious, and you'd have to look into the vias, or sorry, what trace you want to connect to. So it's a lot easier just to click on the trace itself. Okay, so we did a green trace into the via. Now what we want to do is flip to the red trace and click on the trace again. And now you can see we can bypass this bridge that would have been here if we did the green trace. We're basically overlapping it with a via bridge. So we're going to place another via and swap back to the green trace to finish off the connection, which seems to be going up here. So we'll have it go all the way under. Actually, we'll do it from this side, since again the joystick, kind of like an IC, will be, if it's for some reason this trace were to get messed up, it's a little bit more accessible. Well, let's pull this out. Let's do this. Oop, not that. Just gonna extend it. I'll keep it on the outside just so. Oh. Last adjustment. Keeping it on the outside so it's accessible a little bit better. if there is a debug problem. Okay, and we'll get rid of this one too. Nice. All right. Looks like we're going to have another bridge right here that we'll have to handle. But that's all right because we just learned how to do that. So this one is going to be going up to the top. So we can bring this down. We'll do the red layer. Do the red layer. Bring it down to about here. We'll do it to about here. Get our via. Place it on top. Get a green going underneath it. And track. And put another via. Okay, just finish it off like that. That's good. Oh, we have one more 5-volt I totally missed. My bad. Okay, so let's go back and fix that 5-volt. We can put, I should have mentioned this as well. So we can route underneath, like on the opposite layer of an IC or annoying component to desolder. So I have this on the bottom layer. The trace is running there, but not the top layer, because I can access the bottom layer without desoldering the joystick. So that's kind of solved this issue, but we do have a big, we're gonna have to make some kind of bridge again. Oh wait, maybe not. Maybe not. We can run it right here. Let's see. What's a way we could do this? So I would, oh, is that enough clearance? Yeah, I guess that's enough clearance. So I would avoid having an intersection like this because of the whole right angle or the acute angle thing. You see, this is exactly a place that an acid trap could exist in, and we want to avoid this at all costs. Same kind of goes for this little right corner, 90 degrees. It's not ideal, so I have it route under here and use the pad as the intersection point. Okay, so the grounds are fine. We don't have to worry about grounds. Looking like we might have everything connected now. Let's see, grounds. Yeah, this is all right. I think that's all of them but grounds. And you can see it's a lot less. There's not all these white rat's nest lines everywhere. It's just the ground. So next what we're going to do is actually form this ground plane. So what you do on the right hand is click Add Filled Zones, and we're going to be drawing out the plane where essentially the entire shape but the traces will be the ground. We'll start on the top layer. So I select the top layer, make sure I have the right tool, Add Filled tool, and I'm just going to, for now, oh, it's going to make me select it. Okay, ground. And yeah, these are good. I usually keep the default settings. So you're going to have to draw each side of the plane or the shape that you're making. What I like to do is, you can see it's not really a straight line. I'm just moving the mouse and it's pinned to this point. If you hold Control when moving it, it has 45-degree increments for the angle, and then it keeps that angle. So this is how I get straight lines and kind of just eyeball it off the bat. So I hold Control, then I left click, and then I now have to break this side, so I hold Control again, so that's nice and even. Then I left click, hold Control again, and then I left click, and finally I usually zoom into this side, hold Control, left click, and then hit Close Zone Outline. And just like that, we have our first outline. Now, I think what I want to do is move this silk screen annotation. I'm going to move it down to over here. No, I'm going to move it to the top, actually. It's mirrored because, again, this goes on the bottom. So it's just showing a top-down view through the board, essentially. So now that we have this, let's kind of refine the edges to be a little bit more narrow. I'll hold Control while doing this, so that way it's still straight. Just making sure. We'll do the bottom, holding Control and moving it. Okay, do about there. Looks good. And the top's fine. So it's based off of. I should move this in. It's based off of this line, not these squiggles. Squiggles are just there to kind of indicate that's ground. It's like the ground symbol inverted, right? This is the ground. Okay. Now this is only for the top layer. This is the ground plane for the top layer, but we actually want a ground plane for both. So you could draw out a ground plane for the bottom as well, but what I usually do is I just right click and I copy, and it's going to ask for a reference point so it knows where to copy from. Just left click and don't move your mouse. And then I right click again and I hit paste, and then I left click. And now you can't see it, but there's actually two planes here. There's one that's ground and there's one that's no net. So what we need to do is change this to be ground, but on the bottom. Checking all the settings and then we hit OK. Okay, there we go. So now there's a green one, which indicates that it's ground on the bottom. Now there's one more thing what we need to do. Right now, the design or the board, actually let's move it to be centered. There we go. Right now, that's okay for now. The software doesn't know where exactly the edges of the board are. It just knows that these are the ground planes and that there's some board that's going to be at least the size of everything combined. So what we need to do is one more filled zone, but this one's going to be on the layer edge cuts, which just means the edge of the board essentially. So what I do is I just select edge cuts, we're good, and we are just going to outline. Oh, okay, it looks like this ground plane is not straight. So let's go ahead and fix that. Let's fix that somehow. Let's go to properties. Nope, actually. Let's see. Yeah, this is what we'll do. We'll do the bottom, and what we'll do is we'll select the corner, but we'll hold Control, and that will kind of lock it in to be straight. Okay, then we're going to do the same with the red layer. Hold Control and move the corner. Okay, there we go. We want to try to make these as straight as possible. The same thing exists on this side. Looks like it. So again, we'll drag the top while holding Control, and it straightens it out. Do the same with the red. The top looks like it's all right. Okay, so now if we try to make the edge cut filled zone, just click the corner, go to edge cut, holding Control. Oh, make sure when you scroll you don't hold Control because it'll move your screen left and right rather than zooming in. Okay, holding control to make sure it's locked in. I left click, and just the same process that we've been doing. Oh, okay, hold on. So we're gonna place it down, but it seems to me that the red layer is actually not straight. So we'll have to select this. We'll do corner, holding control, move in it. Okay. And the green control. Oh, wait, hold on. Looks like I accidentally deleted the red one. Let's try that again. Let's see. Okay. If there's ever something not selecting, just hit double escape. Okay. Holding control, moving it to the side. Left click, and then we want the front. Holding control, move to the side. Okay. It's all right. No. Always hit Control Z if something disappears and you don't want it to. There we go. Is that right? Nope. We'll do Control there, and then if you're ever unsure. I'm guessing it's overlapping with the yellow, so it can only show one color at a time. The yellow actually has the same shape. But now we have this board. What we need to do now, it looks nice and clean. It came out really good. What I like to do is on whichever side has space. In this case, I'm seeing a lot of space down here on the top plane. Excuse me. So I'm going to hit front silk screen. Oh, there's the ground plane again. Front silk screen. And I'm going to click the add text. And I usually write a few things on here. So this will appear on the board itself. So what I do is I type the name of what the board is. This is a joystick follower, and this is Rev A. Then I come down to the next line. I would write the organization maybe I'm with, the company or club, in this case Mechatronics, and then I write designed by. Now in this case, Pierce and I both worked on it, so I'm going to write designed by Tristan Richmond, and I'm going to do on the next line for convenience, David Walker Howell. Okay, and we'll see how this goes. All right, so we can just place it wherever we want. This looks good, but what I kind of want to do is, make sure you escape. I'm going to select it and right click to change the justification. Right now it's in the center, but we want it to be on the left because I think it looks better. Wonderful. We'll do this, and actually we'll even add a space. Properties. Add a space. Or we could do this. This is just extra at this point. Yeah, no. Sorry. We'll put the new line. Okay. And that's good. Okay. And I should probably mention this before. You should save more often than just at the end, because that would not be fun if this was all broken, or if it crashed and lost all the progress. It can happen to anyone. Okay. We need to now make sure everything is correct and that the system likes what we made. So what we will do, I can't see anything that looks wrong to me. So we'll hit the design wheel check, because what this will do is we'll make sure that everything actually is correct. So we'll hit run DRC, and it looks like everything's good. So we can hit close, and it says our board's nice and ready. So now what we want to do is see how it looks in 3D. So we hit view and hit 3D viewer, or Alt 3 is what usually I click. And bam, there's the board. If you hold shift and left click, you can rotate it around. And each time you let go of shift, it changes the pin. But this is really clean. We could probably, what we'll do actually, we'll move this LED out a little left, so there's a little more space. But regardless, this is not bad. And then you got the back. See, this was the outline I was talking about, the Arduino, because the Arduino will plug in from this side, while our board comes in on the top of it. The Arduino comes from the bottom. Yeah, that's looking great. So we'll close out of this. We will move this ever so slightly, and we'll have to, this is a good thing that I'm actually doing this right here, because it can show you something. Okay, we'll adjust this trace. Look at that, it's even nicer. Oh, not the right track width though. Okay, it's good. As you can see, this ground is now disconnected, and that's because we have to re-pour the ground plane since it was based off of the old setup. This a little bit. And we'll move this. Trace tool. Hopefully by now you got the hang of everything and feeling pretty comfortable with designing a PCB. Okay, so to re-pour the plane so it works, we just have to simply go to the design rule check and we hit run DRC. It's going to say that we need to refill some zones. We click refill, and that's good. And that ground line is gone. Everything's nice. Now, if you ever have a case where you do the ground plane pour and you do the run DRC check and there's still a line, that means that there's an island of your grounds. Meaning, if I, for example, wanted, if my trace is completely surrounded, it's completely surrounded, completely surrounded a plane or a ground pin, what would happen is if we run, oh, not that one, sorry, run this to re-pour, it's not technically connected on the top ground plane. Of course, since these vias attach to the top and the bottom, it's attached to the bottom ground plane, but not the top, because the ground plane poured everywhere else but here. And that's a problem. So a way you can fix that, if there wasn't a via here, and let's say it was a pad, like for surface mount components, they don't access both sides, they only access the top side. Let's say this was a pad. What you would want to do is take a via, place it around it, place them around it, and change them all to be ground. See, it'll automatically do that because it's a through hole and it knows that this is supposed to be ground. But that's one way you can save an island. Let's see, anything else that I can think of before moving on past this? So yeah, just avoid right angles. If you have islands, make sure you connect it to the plane with the vias. If you want to cross stuff, use vias to get to the other side, like a bridge. It's like inner dimension traveling. It's pretty good stuff. Yeah, I think that's about it. So one last thing, we're gonna run a check to make sure. We're gonna refill. We're gonna hit Alt 3 to go into the 3D view. Once it loads. Oh, maybe, yeah, there we go. Okay, that looks a little bit better. Of course, these ones are closer than this, but you know, now that there's, oh, actually, yeah, gotta make sure that we don't intersect that, like we said before. The trace is fine, but any mechanical or component shouldn't intersect that. Okay, this is looking great. Making sure we're not in these boundaries. Yeah, we have our name here. Okay, so the very last step. You want to order this board now. Typically, you would go through a company, a manufacturing board company, and you would send them the files for this board to be made. So what you're going to do for that is you're going to go to File and go to Plot, and you're going to have this screen pop up. What you're going to want to do is create a new folder rather. It's going to ask you which folder you want to use. I always create a new folder, and I name it Gerbers because it's going to generate a lot of files, and it's much better to have them all in one place, and this is fine. Hit yes to this. Now I don't mess with any settings usually. We just have to make sure for sure that the front and bottom layers are included. These paste layers are included, the silk screens are included, the masks are included, and the edge cuts. All of these are important to have. Otherwise, what we can do is hit, gonna hit generate. Yeah, hit generate drill files. These settings are good as well. Nothing needed here. I'm gonna hit generate drill file. That's the first one. We hit close. And then we go to the plot. That's a little bit different. I didn't expect it to close, but that's okay. One last thing, we're gonna hit plot, and it generated a bunch more files. And we hit close, and we go to our projects, and we have a Gerber file here, or folder, and all of our stuff that we would need to send to a company would be right there. So usually we go through at Mechatronics, we go through JLC PCB, and just for ease, we'll hit quote now, and we right here we just add our Gerber file. Let's see if it'll work. So we locate where exactly. Let's see, where did I put it? Mechatronics. We locate where exactly that Gerber file or folder is. I'm gonna hit open, and all of these. Actually, we need to send it to a zip. Send it to a compressed folder, same name, and it's gonna upload. And what should happen is it say you're doing great, and it'll provide a preview once this loads. We have all these settings that it will kind of give by default. Usually the best settings for the cheapest price too. I know if you have a different PCB color. Oh, okay, this is good. So it changed the dimensions because it noticed that our board was that size. It also detected 2 layers, so there's 2 layers here. By minimum, you can only order 5, but this is good because if one breaks, you just repopulate the other, usually by 5 at least. This is all just one design, one single PCB. This is a good thickness. You can have it a little more thicker. I'm not too sure about the benefits of that. I just know it makes it more expensive. We have green as a PCB color for the fastest shipping time, but you can have other times, other colors. It'll just take longer. You can have different surface finishes. I usually just use a default. I do the default for all of these actually. And yeah, when I'm done, if you want, they sometimes can populate the board for you. If you add this, I'm not too sure the process behind that, but it's an option. So that way you don't have to solder at all. They'll sometimes just add a very small fee to your order and solder a bunch of components onto it. But it has to be surface mount. In our case, it's through hole, so we can't really do that. And then a stencil is if you're using solder paste. They'll come with a stencil, and you'll just solder it with a stencil over the PCB, but that's its own discussion. But yeah, this is the entire process of JLC, and this is really kind of how we're wrapping up. Just making sure this is all done. Let's go to the 3D view. So this is how you make your own PCB in KiCAD. I know it's a lot of information, and this video is a little longer than I wanted it to be, but hopefully you can parse through it and find the stuff you need to, and build your own PCB. And hopefully you're able to follow along with this and have a product that a board that you organized and built and feel proud of. So thanks for watching. Good luck. If you ever have any questions about making a PCB, KiCAD has a big community, so there's plenty of resources online, other YouTube videos, and just use the internet to your advantage whenever you want to figure something out. Other than that, thanks for watching and good luck making your PCBs.